So when we think about, if say the manipulated variable about light is that the frequency of the light increases, so the frequency, that's like your F. So the way that I think about that is if your F is increasing, think about that, that's like the energy of a photon is increasing, okay? So it's like one individual photon's energy increases. So then the kinetic energy of the ejected electrons increases because it's like one photon per one electron. If there's more energy coming in, there's more energy going out, okay? So when you think about the word frequency, think about it as the variable F, not as like more frequent. Think about energy per frequency, okay? Then if, say, the light, we increase the intensity of the light, so that is like the number of photons. So that's the amount of photons coming in. Now, if the amount of photons coming in increases, even if the frequency of that light is really low, it might still not emit any electrons, or like, have any electrons bounce off. The frequency has to be past the threshold. But if it's past the threshold and the intensity of the light increases, that's the number of photons, then we'll have number of electrons emitted will increase. So think about it again as one photon to one electron. So if the number of photons increases and it's past threshold frequency, then number of electrons will increase. These are really, 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 really important for you to remember. Extremely important. It will be important for you to make graphs of these things, these assumptions. Very important. Okay, so either think about it logically and you can just remember it, or you might have to memorize it if you have a hard time thinking about it logically. Just depends how you process these things. So let's try and do these, representing these graphically. So this is kinetic energy of electrons versus intensity of the incoming light. So if the intensity of light increases, so that's like number of photons I'm going to put down just to kind of help me remember what that is. Say intensity increases, will the kinetic energy of the electrons increase, decrease, stay the same? If the number of photons increases, the kinetic energy will increase? No. If the number of photons increases, only the number of electrons will increase. The only thing that can change the energy of the electrons is the energy of the photons, which is frequency. See? That's why this is so hard, okay? Because it's frequency, energy, whatnot, okay? So when we think about then intensity increasing, that's our number of photons, it doesn't matter how many photons you hit at it, the energy that each electron has leaving is going to be the same. If frequency doesn't change, it will be the same. Okay? No matter how many lights you shine on it, the energy leaving will be the same. There will be more electrons leaving, but the energy of each electron will be the same. Let's do and it gives us this contingency that the frequency of the light is greater than the threshold. So that assumes, that basically tells us that there will be photoelectrons, meaning that electrons will be bounced off of the surface of the metal due to the incident photons. That's what photoelectrons means. Electrons bounced off due to photons. Now, how about do this one? Kinetic energy versus intensity, where the frequency of light is less than the threshold. So will any electrons be emitted? No. No electrons will be like released or whatever, okay? So the amount of kinetic energy is 0 because there is no kinetic energy of the electrons because they are still held within inside their metallic bonds. They're not moving. So now let's think about this one. Current, think about current as number of electrons. Because if we think about the current of a wire, that means how many electrons. So think about that number of electrons. Now wavelength is kind of another way of talking about energy. Okay? With increased frequency, we had increased energy. What happens with wavelength? It gets smaller. So if we're going to say in our graph wavelength is increasing, that means increase in wavelength means decrease in energy. So if you're doing a test where you have to manipulate or understand graphs, take those variables, those axes, and kind of put it into context that you can think about it logically. So if my wavelength, say, if I have increased wavelength, will it influence my current? No, because it's the energy, right? So I'm going to say, okay, no, but there's going to be a certain level where wavelength gets too high and there won't be any emitted electrons at all. And we would call that spot where it's just too high, meaning too low of energy, that this is called wavelength max, okay? Which is the lowest energy. So whatever wavelength maximum is, you would be able to find your threshold frequency. See how it's kind of like a threshold wavelength, okay? So we can think about this as threshold wavelength. So you could take that wavelength maximum, and you know your speed is always 3 times 10 to the 8th, and you can find your frequency. Okay? So how about this one, where we have the energy, the kinetic energy of the emitted electrons versus the wavelength of the incident light. So let's think about this. If we're dealing with energy, it's like we have our E is equal to H times C over lambda. So we're assuming, and then there'll be the work function too. So our energy that's being converted compared to wavelength, okay, it's E is proportional to 1 over wavelength then, if we're just looking at those two variables and how they're related to one another. So how we could represent this then is where we have a relationship like this, but wavelength, if once it gets too high, again, will drop and no electrons would be emitted. Okay, again, this is, then we would call this lambda max, or, like I said, I would think about this as the threshold lambda, or even if I think about it in another way, this is like the minimum energy, right? So that's like the minimum energy needed to be able to have the kinetic energy of electrons. However, some graphs for photoelectric effect require a bit more analysis and calculations than just these conclusions. So let's look at one of these. These are actually, I kind of think they're fun. So let's try one out.